I want to start off with the scope and signal generator with noting that this is for the signal generator. BNC on one side and then just gator clips on the other. This is for a scope, not for signal generator. Don't get them swapped up. And what we're doing here is I just have scope and signal generator here, and I can connect them. I just have a single resistor. They're hooked up. And then up here we have our brand new BK Precision scope or signal generator and our Rigol scope. We've done videos on the scope before. It's important to note that this is commonly grounded to the BNC plugs over here. And I'll prove that here in a second. But first, let's look at this thing. This is nice. So what I've got is I've got two channels, and you have to set which channel you want, channel 1 or channel 2. So you can select which one, and we can digitally set the frequency and the voltage, the phase, and the offset, just like that. Now, it doesn't automatically output, let's say I've got it set up, output, suddenly it's there. Now, to prove my point about common grounding, if I take this away, so we can't read it with the signal generator, look, it's still there. Nothing changed at all. And while you're looking, I will clip it. It's clipped, it's unclipped. Now, there is a slight difference when I unhook the signal generator, and that's because it has an output impedance, and we just added a load to it, so the voltage drops slightly when I disconnect it, okay? So that's the basic of that. The nice part, though, is that I have two outputs. I'm going to turn this one off right now, and I can come over here and set my frequency, okay? And I'm just dialing it in. It goes up automatically. Okay, I think I have to move it over one to keep it going. But I've used some other scopes before, or signal generators, and this one is by far the nicest as far as user interface. Okay, and we can set the output, and you can tell that the frequency went up, and I can even change it as we go. Okay, this one has, it looks like, so we can do frequency period, we can set a frequency or a period, amplitude or H level, so amplitude is 4, offset, low level, phase, equiphase, and there should be some way that we can do, yeah, so there's all sorts of different options here, utility, restore recall, so that's all that stuff. We can set a different waveform. Here's a square, a ramp, okay? And then we can look at symmetry on this one. It's very nice. Sine wave, we don't get symmetry, so it's always a sine wave. In other words, on other signal generators, you can do a duty cycle. Same with this one, we can do a duty cycle. But this only lets us get down to about, what is that, a 10% duty, 20% duty cycle? And maybe it lets us. It doesn't let us get below a 20, which is kind of interesting. Okay? Okay, what else can we do with this? We can do noise, an arbitrary waveform, which I believe you can load in through the USB stick. Okay? And so you can load it from someplace else, which is kind of nice. And you may even on these be able to load it through a USB port on the back. And so that's something to be explored further, but I don't have that set up right now. Let's see, so that's noise, pulse, ramp, sine. Now, I think the ultimate on this one that we haven't had in past in this lab is we can add in a second channel. Okay? And so I'm going to add in our second channel of scope and second channel of voltage regulators, completely separate resistor. So if you want to see it, I'll show it to you. But I'm hooking it up to a different resistor, so these are completely independent, obviously other than the common grounding. Okay, so that one's hooked up. So you can see it's not going to mean much, but you can look. And now I have 2 resistors, 2 scopes, 2 signal generators. And what's nice is these guys are going to be they're perfectly in phase. And that's what's really nice. Now I can go and add a different frequency. Let's get to a multiple. Okay? And it's glitching back and forth because it's twice the frequency. So we've got a trigger on channel 1, not on channel 2. So let's go to half the frequency. Let's go to 500. Now it's not glitching because it's half the frequency of channel 2. And so we can change that. No, that was channel 1. Sorry, I was messing with channel 1. So if I mess with channel 2, go down in frequency on this one. And so it's got a little bit of, like, I've got to go down to 250, and it's got a little bit of glitch there, and that's because we're triggering on channel 1, and there's a duplicate on channel 2, right? Which is kind of nice. I can change the amplitude of channel 2 now. But I think the ultimate thing that this is great for is phase. Let me get them to the same frequency. Oops. I can also just dial in 1, 0, 0. Okay, I didn't mean to do that. Kilohertz. There. Now they're exactly in, but now you can definitely see the phase shift. Let me go back to channel 1. We'll put this one back to 1, 0, 0, 0 hertz. Okay, so they're directly in phase. I'm going to go back to channel 2 and look at phase. Ooh. And let's do something cool like 90. 90 degrees. So you can see it's right there. So that's really handy. We can do some really cool experimentation. So I'm going to have to remake some labs for this, where we have 2 input signals, not just 1. And we can see them both on here. We can add in an offset on one of them, so we can see the offset. And we'll just do a 2 volt. There. So we did a 2 volt offset on the one. We can see that one pop up. And of course, just as a reminder, as we're looking at channel 2 here, if we wanted to, we can switch this to AC coupled, and the offset magically goes away. That's because we're AC coupled. One of the first things that you do with the scope when you come in is you come in and look at the 2 channels. Oh, that one's AC coupled. Better switch it back to DC if you want to be in DC land. But that's the basics. I'm going to let you guys play around with the BK Precision signal generator. It's pretty fun and really intuitive compared to other models I've used.